Hello everyone, welcome to this video. From this video onwards, we'll be studying about properties of isomorphisms. So if we assume that phi is some isomorphism from a group G to a group G bar, right? So that means we have phi which is a mapping defined from G to G bar, and it is given to be an isomorphism. So we are given the property of 1 1 on 2 and operation preserving, correct? If these properties are given to us, in that case, what do we have as the first property? As the first property, we have that if phi carries the identity of the group G to the identity of the group G bar, right? So if we assume for the proof, what we do, if we assume that let E1 represents the identity of G, and E2 represents the identity of the group G bar, correct? This is our assumption. Then what we have to prove? Then we need to prove that this mapping phi, when it maps the first identity of the group G1 to the second identity, right? So this is what we wanted to prove here. For that, we assume that let G is some element which is equal to phi of E1. So we would like to prove that G is equal to E2, right? For that, what we do, we take the square of G. So it would be phi of E1 square, right? So that means we may write this as phi of E1 into phi of E1, right? So what does it mean? It means that we can combine this E1 into E1. Why? Because we have operation preserving property by the operation preserving property, right? So what is this? This is phi of E1 square. What is E1 square? The square of identity, that is identity only, so it is phi of E1. And what is phi of E1? We have assumed this to be G, so we obtained G square is equal to G, right? From here, what do we have? This implies that we may post multiply on both sides of this equation by G inverse, so that we would have this thing over here. So from here we would have the value of left hand side becomes G, and the value of right hand side, it becomes the identity in E2. Why? Because G was equal to what? It was phi of E1, and it was a member of G bar. So therefore this G into G inverse would be equal to the identity of the group G bar, right? So therefore G is equal to E2. So this implies phi of E1 is equal to E2, and this is what we wanted to prove here. So this is our proof. So I hope you understood this property here. Well, that is it for this video. Thank you for watching.